We're actually going to move on to counting down to Casper with Meta from Casper Labs. Meta, are you here?
Can you guys hear me okay?
We can hear you just fine. Are you ready to count us down?
I'm ready to count you guys down.
Okay, well, take it away.
All right, thank you. Thanks everyone for having me on today. I'm Meta Parlikar, the CTO of Casper Labs, the company that's building the software that will power the Casper network. I'm excited to be presenting today, and I look forward, hopefully, to seeing everyone in person soon. Today, I'll share some of the interesting features that Casper has as we count down to our mainnet launch. We're going to keep this high level because we have a broad mix of folks in the audience, I'm sure. And at the end, I'll share some information about how you can get in touch with us if you have questions. So Casper is a new layer 1 smart contracting platform that takes inspiration from Ethereum research, specifically the CBC Casper paper, in case you can't tell from our name. I'll provide a high-level overview of the public Casper network, which will dig into each of these important areas and how Casper will help further the adoption of blockchain technology by business and end users. There is a great deal of research taking place in consensus protocols, and we're no exception here. Our team spent 2 years working on the Highway Protocol, a member of the CBC Casper family of protocols. The framework from Ethereum research on CBC Casper provides a specification for a family of consensus protocols based on these principles. They have to be proof of stake that use the latest message-driven ghost rule, which involves stake-weighted voting. They have to use a finality oracle. With this traditional CBC Casper paper, you can have any kind of finality detection the client wishes. But in Highway, we do require a 2/3 quorum in order to finalize a block. The protocols have to be provably safe. Decisions once made cannot be reverted. And they have to provide economic security through slashing and incentives. In addition to all of this, Highway also has a liveness strategy that ensures that a block is mined by a leader. And this is all structured around what we call eras or epochs. We're also really happy to report that we followed the CBC method of developing this protocol because we started with a formal math paper and then went into code implementation. And all of this was verified in a very successful audit with Trail of Bits. In addition to all of this, the protocol is also resistant to several attacks that are commonly found in a lot of the fork choice-based protocols. You can find the Casper paper, the Highway paper, on our website at casperlabs.io. Now, Highway is structured as a permissioned protocol. The participants in a given era are fixed, but we all know that permissionless is the way to go. So let's talk about how we made Highway permissionless. As we know, blockchains get real security from decentralization and being permissionless. And we see this with Ethereum and Bitcoin. This is one of the reasons they have been unstoppable. The Casper protocol will rotate the validator set every 30 minutes via an on-chain contract, which is currently called the auction contract. The contract will run every era and select the top N stake bids and create the validator set for a future era. Presently, it creates the validator set for 3 eras in the future. A validator's bid into the contract is a combination of its own stake plus the stake of all the delegators that have chosen to stake with them. Any token holder that custodies their own keys can select any validator to stake their tokens with. This stake helps the validator increase their chances of being selected via the on-chain contract. Now here, delegators have a real opportunity to influence the validator set. And while this does happen in delegated proof-of-stake protocols, the incentive mechanisms are not as strong as they are here. Selecting a reputable validator for delegating is really important. And we believe this form of validator selection encourages validators to provide great service and develop a good reputation in order to attract delegators. And as we will discuss in the next slide, this is really important because of the security properties, the economic security properties of the protocol. Public blockchain infrastructure is expensive, so it had better provide security for the price. With a permissionless network, anyone can join. It's possible to fork the code base and create a malicious instance of the protocol and mount an attack. In proof-of-stake protocols, a big component of security comes from slashing. Particularly in a permissionless network, it ensures that malicious actions that attempt to revert honest transactions are penalized. And this protocol security we talk of is directly proportional to the slashing penalty. If the rewards from reverting a decision exceed the risks associated with slashing, then the attack is considered profitable for a malicious validator. In this regard, proof-of-stake can provide more security than proof-of-work, because mounting an attack where decisions are reverted results in a slash of the stake of the attacker. Whereas in proof-of-work, the attacker can mine a different fork, and while the time and energy is lost, no one is coming in through the front door to take their rig. Highway doesn't use statistical or probabilistic security. This way, it's different than a lot of the other proof-of-stake protocols out there. For every block, 2/3 of all stake must vote on the block before transactions are executed and the block is considered finalized. Casper performs execution after consensus, which eliminates orphans and any questions around whether a given transaction is finalized or not. This means validators have to attest to blocks. If they don't vote, they do not get rewards and will eventually get the boot by the protocol. Validators following the protocol will not be slashed because they will make consistent decisions and they are rewarded by the protocol for providing security and processing transactions. And those validators that revert decisions or make inconsistent decisions, and this is technically called an equivocation, are slashed. Slashing is 100% of stake, and their delegators are also slashed along with them. So here you can see when you're delegating your tokens to a validator, it's really important that you do your due diligence and research the validator that you're going to be entrusting your tokens to. Because if they do something wrong, you're going to get slashed along with them. Now that we've talked about the security of the protocol, let's go into some of the interesting features that Casper offers. So we know that software has been governed by organizations since the beginning. For every update, there are complex approval processes, agreement on the change log, and sign off before changes are updated. We knew this at Casper Labs, and so we felt that building tools for contract authors to manage their on-chain code was absolutely essential. Therefore, our smart contract packaging tools enable organizations to upgrade their contracts and specify how the state of the contract is managed during an upgrade, specify whether a contract is upgradable or immutable, version their contracts and deprecate old versions of contracts, set permissions around who can perform a contract upgrade, and during a protocol fork, contracts will need to be upgraded to ensure that they're compliant with the new protocol versions. And all of this is possible on-chain, and it doesn't really matter whether the protocol is centrally controlled or decentrally controlled via a DAO or a governed community that chooses to govern the protocol. All of these features are available as part of a contract package on the Casper network. We believe that a protocol needs to enable developers to do what they need to do to manage their contracts and businesses to manage their logic using the blockchain. And for decentralized protocols, they all need the same tools, and it becomes even more important because they're not centrally organized, and you need the additional trust and verifiability that comes with the blockchain, which is why all these tools become even more important for decentralized protocols. Now let's go into some of the really interesting account features that enable these governance tools. So governing the on-chain code is essential, and regardless of what the code does, right? And we believe that a platform should provide core capabilities. Now down here in the blue, we're showing the core capabilities that the platform provides. And up here on the white, we're showing the features that you can use those core capabilities when you create features using it. So we provide support for multiple key types, and this reduces cross-chain user account friction. So for example, if you have existing Ethereum keys, you can use those existing keys and create accounts on Casper using Ethereum keys and sign transaction using your existing keys. And if you want to build any kind of cross blockchain compatibility using a smart contract, you don't need to recreate user accounts. You can use existing user accounts on the Casper protocol. Additionally, you can separate permissions for actions, which are basically signing of transactions on the account, or granting the ability to manage keys. So say, for example, if I want to let my 3 friends recover my keys in the event I've lost my key, I can just grant the authority to their public keys on my account, and nobody has to share private keys. And you don't have to use a layer 2 protocol to do this. You can do it directly just by executing a transaction against my account. Then my friends can all sign a key recovery transaction and help me recover my keys on chain, and we don't have to share private keys whatsoever. So that allows people to recover and delegate and save keys. You can also govern your protocol using account weights, which is much, much more egalitarian than, say, having a governance token where people can just buy their way into the protocol. If you're running a centralized business, you can grant temporary access to one of your user accounts via your support team by authorizing the user, letting the user authorize your support team access to their account. And you can also build features to manage user accounts for your project, right? So if you want to have account management features within your protocol, you can also leverage this to actually build account features within the protocol itself. And even if you don't need these advanced features today, you don't want to implement against a protocol where you don't have them in the event you need them in the future. So sometimes success can be the greatest thing that scares you, right? I mean, if your protocol is really, really successful and you need the features in the future, if you don't select a layer 1 that offers this, you're going to have to build all of this into your contract, and you're going to have to build it on layer 2, which will give you fewer security guarantees. So now let's talk a little bit about managing code and building these kinds of applications. We offer a fantastic developer user experience, which is an integrated Rust experience for starters. And this is very similar to the experience that Web 2 developers are familiar with. It's a lot like Java and C++, where you can run and build your code locally within an IDE and use assertions and tests to verify the functionality of the smart contract. It's possible to set the starting state of the contract and to write tests and create assertions, which is what I'm showing here on my screen. This VM will run within an IDE, all using the Cargo Casper, and it's 2 simple commands: cargo install Cargo Casper, and then you can create your empty project. And because we use WebAssembly, we can add more compilation targets as they become available. And these are contract libraries that are separate to the virtual machine, so we can deliver them without a hard fork. Now let's talk a little bit about how you will deliver a complex application architecture, be it if you have an existing architecture and you want to use blockchain, or if you're building something from the ground up. So when a blockchain can be part of a larger application architecture, contracts have to build alongside the application. Casper provides the instrumentation and tooling that integrates with existing pipelines seamlessly. So build servers can run this little VM without the overhead of a full node, and it can track the blockchain internal state and run assertions and tests, all using continuous integration, continuous deployment. And in almost every organization where I worked, the first problem I was tasked to solve was around development operations and having a pipeline. And having a solid pipeline is absolutely critical to quality software delivery and being able to keep up with market changes and customer support requests. We're very close to mainnet, and we're very excited to have even more of the community join us as we get ready for our launch. We'll have updates soon, but in the meantime, please join our Discord, join us on Telegram, become a part of our community, join us in ushering a new era with the CBC Casper protocol. Thank you very much for joining me today, and I look forward to seeing you at future ETH hackathons. Bye.